Hi everyone, welcome to Coley Teaches Math. So today we're going to do Unit 2 review, basic derivatives. All right, so what topics do we have? I kind of grouped them how I teach them in class. So the topics that we have in this unit review are going to be the definition of the derivative, the power rule, the product rule, the quotient rule, trig, exponential, and natural log derivatives, and differentiability. So let's go to our first topic, which is going to be the definition of the derivative. So when you first learned how to take derivatives, you learned how to use something called the difference quotient, which is right here. So the difference quotient. And that was like the really long way to find derivatives. Now, what is a derivative? You need to understand that the derivative is the slope of the tangent line. So I need you to think slope, derivative, slope, derivative. And it's specifically the slope of the tangent line. And it's the instantaneous rate of change. So it's going to be the rate of change at a point. Now, if you look at these two examples that I have right here, these are asking you to actually take the derivative, even though they don't say derive. So I like to call these two examples right here disguised derivatives. So that's how I refer to it in my class, because it's actually a derivative question, not a limit question. Because if you look here and you say to yourself, oh, that's a limit question. Let me replace h with 0. Well, if you replace h with 0, you're going to get 0 over 0. And if you watched my last review, you know that means we got to do something else. So what you're going to do is you're going to kind of look to see how this, I guess, let's say, mimics the difference quotient, because it is. So do you see right here, whatever follows the subtraction sign is f of x? So cosine follows the subtraction sign. So step one, you're going to want to identify the function. So the function is going to be cosine x. It's a function of x, so it's not cosine pi over 2. If you notice, the pi over 2 is in the spot of the x. So the function's cosine x. Step two, we're going to take the derivative because of this limit as h approaches 0 in front. So we're going to take the derivative of the function, so negative sine x. And then step three, we are going to evaluate the derivative at that x value, so at pi over 2. So if we replace x with pi over 2, this would be negative 1. So if this was a multiple choice, which it most likely will be, the answer that we are circling is negative 1. Okay? Okay, look here. So, same thing. Notice that the 25 is in the spot of the x. Whatever follows the subtraction sign is your function. So step one, my function is rad x. I taught my kids to memorize that rad x derives to 1 over 2 rad x. It just makes it so much easier to do things with. And now what did we throw an x over? 25. So they're asking me to do f prime of 25, which is going to be this. If you simplify that, that's going to be 1/10. Okay? So we need to know how to do disguised derivatives. All right, first rule that you guys learned to take derivatives is the power rule. So the rule is bring down the power, keep the variable, subtract 1 from the power. So we're going to go ahead and apply that rule to these 4 examples here. All right, first one, we're going to multiply the powers to get 9x squared, and then multiply the coefficient and the exponent, and then subtract 1 from the power. Easy peasy. The derivative of negative 4x is just going to be negative 4. It's just going to be the constant attached to the variable. We just said memorize rad x derives to 1 over 2 rad x. It just makes your life easier. And then the derivative of a constant is going to be 0. So that's important to remember. Derivative of constant equals 0. You will most likely not have to simplify on the AP exam, like in the multiple choice. I don't think they would do anything else with that. All right, next example. First thing I like to do is I like to rewrite everything to work with, like to be easier to work with. So watch. X to the 4th, there's nothing I can do. But do you see this? 1 over x cubed. I'm going to bring up the exponent by negating it. And I'm going to turn things, we don't like roots, we like fractional exponents. So first thing I'm going to do is no calculus. I'm just rewriting it. And now I'm going to go ahead and take the derivative. So we're going to get 4x cubed Negative times a negative plus 3x to the minus 4 plus 1/3 x, take away 1 from that power. So take away 3 over 3 from that, negative 2/3 minus 10x. Okay, done. That is my answer right here. All right, come over here to this one. So we don't know the quotient rule yet. You could use the quotient rule in a minute, but for right now, we don't know the quotient rule. So I'm going to do something that I like to call the heart method in my class. So I'm essentially going to simplify this fraction before I derive it. And when I say simplify, we're going to give every term up top the denominator of x. So see what I'm doing here? Then we're going to simplify it. So subtract the powers, that's 3x to the 6th. And you know I like to bring variables up. So I'm actually going to bring up the x to make it negative 5x to the negative 1. All right, let's do it. Let's derive this. So that's going to be 18x to the 5th plus 5x to the negative 2. Okay, done. And last but not least is this one right here, multiplying two binomials. I would never use the product rule for something like this. I would actually double distribute this out first. So you're going to get x squared plus x minus 6, and then I would derive it. Like all the time, that's how I would do it. Okay, so that's the power rule. All right, next, product rule. Who doesn't love a good product rule? So you're going to use this when you obviously have a product of two functions. So we have uv here. So it's going to be u v prime plus v u prime. Now, when you first learn product rule, you probably learned to write it out like this. You can still do that. But the way I teach it to kind of save us some time is I kind of say, okay, guys, choose one of them to be, the first one's u, the second one's v. And now watch as I'm saying it, how I'm writing it. So we're going to have u v prime. So the derivative of v is 9x squared. Plus v u prime. The derivative of u is 2x plus 5. Now, the AP could certainly simplify this, and you would have to distribute it, but we're not going to do that right now. So that is using the product rule. Let's do this next one here. Call this u, call this v. So now watch me do the derivative. We're going to have u v prime. So the derivative of v is going to be 8x plus v u prime is just 1 over 2 at x. Done. Love a good product rule. All right, quotient rule. So this is the one where my kids make fun of me sometimes with how I say it. There's two ways you can memorize this. You can memorize it with u's and v's, and you can memorize it with this little jingle that I'm going to say in a second. So if you memorize it with u's and v's, it's going to be bottom times the derivative of the top, so vu prime, minus top times derivative of the bottom, all over the bottom square. So some kids memorize it like that. I like to teach it like that, basically, but I like to call u the high function and v the low function. So then the derivative is going to be low d high. So when I say d high, I'm sorry, low d high, because that's going to be v u prime minus high d low all over low low. When I say d high, I don't know why I wrote di for, sorry, it's been a long day. Low d high. When I say d high, I mean the derivative of the top function. So d high means the derivative of the top. D low means the derivative of the bottom. So if you like that little jingle, use it when you're deriving. I do say it in class. So watch. This is u, this is v, or the high function and the low function. All right, let's do it. Low d high. So the derivative of the top is 2x minus 4. Minus high d low, the derivative of the bottom is 3. All over low low. Okay, how could you simplify that? You can distribute and combine like terms, but we're not going to do that right now. Okay, and now come over here to this example. So this is my high, this is my low. So we're gonna have low d high, 20x cubed, minus high d low, 2x minus 2, all over low low. Done. Okay, so the quotient rule you are probably going to have to use somewhere on the AP. Usually in the free response, they love a good quotient rule and all that fun stuff. All right, next one. Trig, exponential, natural log. You have to memorize this section. So let's go through and write down the derivatives of all these trig functions. So the derivative of sine is cosine. Derivative of cosine is negative sine. Derivative of tangent is secant squared. Derivative of secant is secant x tan x. Derivative of cosecant is negative cosecant x cotangent x. And the derivative of cotan is negative cosecant squared x. If you notice, everything that I'm highlighting starts with the c. Every function. And all of those functions have negative derivatives. So that's how you can remember which ones go with, like, which ones are negative. All right. Before I move on, let's do these two examples. So if you look at this first example, we're going to use a product rule here, u and v. So we're going to have u, v prime, the derivative of v is negative sine x, plus v, u prime, the derivative of sine is going to be cosine. Now, I am going to just make this a little bit prettier so I can move that down. When I say make it prettier, check this out. The negative, I'm going to bring in front, sine squared x plus cosine squared x. Done. All right, look at this next example. We're going to quotient rule this, high and low. So we're going to have low d high, the derivative of cosecant is negative cosecant cotangent. Low d high minus high d low, the derivative of tan is secant squared, all over low low. And then here's one where they're asking us to evaluate the derivative at a point. So they want us to find f prime of pi over 6. So let's first find the derivative. So the derivative of sine is cosine. And then we're going to plug in pi over 6. So I need to figure out what the cosine of pi over 6 is. And you can use whatever method you like. If you like the triangles, you use the triangles. If you like to remember the chart, but you have to know it. So the cosine of pi over 6 is going to be the cosine of 30. Adjacent over hypotenuse, it's going to be rad 3 over 2. Okay? All right. Let's just double check. All right. Next, we're going to derive e. So to derive e, you're going to recopy it times the derivative of the power. So u prime means derivative of exponent. So here we go. Look at this one. Recopy it times the derivative of the power. So the derivative of the power is going to be 6x. I like to bring the derivative in front. Same thing. Recopy it. Multiply by the derivative of the power, 1 over 2 rad x. Done. And last but not least, look at this one. u, v. So now we're going to have u, v prime. So the derivative of v is recopy the e times the derivative of the power plus v, and then u prime is just secant tangent. Done. All right, natural log. So to derive natural log, you're going to do 1 over u times u prime or u prime over u, however you want to do it. So I'm going to highlight all of the u's, this, and that. So let's do it. So this first one is going to be 1 over u. So I have the u right there, times the derivative of u, which is going to be 4. So obviously that's going to be 4 over 4x plus 5. All right, next one. it's going to be 1 over u times the derivative of u. So the derivative of cotan is negative cosecant squared x. You can rewrite that as negative cosecant squared x over cotan. And now this one requires us to use the product rule. So let's do it. U v prime, so the derivative of ln of x is going to be 1 over u times the derivative of u, which is just 1. You guys should probably just memorize ln of x goes to 1 over x. Plus v, and then u prime, the derivative of e to the x is itself, e to the x. Done. All right. And last but not least, let's chat about what it means to be differentiable. So in order to be differentiable, we need to be continuous first. And you have to know that differentiability in calculus, so differentiability, ability, implies continuity. So if the AP says we're differentiable, we are automatically continuous. But continuity does not imply differentiability. So in order to be differentiable, the derivative has to exist everywhere. So we are not differentiable if the function's not continuous. If the function has a sharp point, so the most famous sharp point functions are absolute value. I am continuous, but I'm not differentiable because we got a sharp point right here. And then at vertical tangent. So vertical tangent is a spot where the slope is undefined. So you see what I just drew there? So right here, the slope is going to be undefined. So that's going to be the vertical tangent, okay? And the slope is bad when it's undefined. So what do we need to be able to do with this? On the next page, we need to be able to identify on a graph where the function's continuous but not differentiable. So I'm going to actually go through each points on the graph and just chat about them. So you see this first point right here? So let's chat about this. So the limit does exist here. The limit exists, but we're not continuous because we fail the fact that f of 0 has to exist. So f of 0 doesn't exist. That's the first limit law that we fail. So if we're not continuous, we're automatically not differentiable. So this hole right here, bad. All right, next spot. I'll do different colors. See this point right here? That's a sharp point. We are continuous there because I can draw it without picking up my pencil, but we are not differentiable. Same here. We are continuous but not differentiable. And then last but not least, same here. We're continuous but not differentiable. And we're not differentiable here because there's a vertical tangent. And last but not least, they love these questions. Find the value of a and b that will make the function differentiable. All right, so the quickest way to do this is to kind of split it. So in order to be differentiable, we need to be continuous first. And if you watched my last unit review, I did a question like this to find the value of a to make it continuous. Well, in order to be continuous, the limit from the left and the limit from the right have to be equal. That's what I'm doing right here. I did the left-hand limit equal the right-hand limit. And I'm going to replace x with 1 because that's what the piecewise function is split up over. So if I replace x with 1 and I solve, we get 5 equals a plus b. I'm going to put that in a cloud because that's one equation that I need. And now over here, we're going to deal with the differentiability part. Well, in order to be differentiable, the derivative has to exist. So in order to be differentiable, the limit of the derivative from the left and right have to match. So what do you need to do? You need to take the derivative of this piecewise function. So let's just derive each piece. But what I'm highlighting in black are constants. So the derivative of ax plus b is just going to be a. You know why? If I asked you guys to derive 2x plus 7, wouldn't that derivative just be 2? Because 2 and 7 are constants. Same thing. A and b are constants. And then the derivative of the bottom is going to be 10x. You're going to set the left-hand derivative equal to the right-hand derivative. I said it backwards. But you're just setting the top and bottom piece equal to each other. Replacing x with 1. So So if I do that, we right away know A is 10. Well, if A is 10 and you solve for B, B is negative 5. Please pay attention on the AP. Sometimes they ask you for the value of A plus B. Sometimes they just say the value of A. Sometimes they just say the value of B. And that is Unit 2.